Hello guys, in the previous video we managed to solve the day 8 of the Advent of Code 2024, and this video let's start solving the day 9. But yeah, without further ado, let's jump to the day 9 challenge here. Let's start coding. Yes, so day 9, disk fragmenter. Another push of the button leaves you in the familiar hallways of some friendly amphipods. Good thing you each somehow got own personal mini-submarine. The historians yet away in search of the chief, mostly by driving directly into walls. While the historians quickly figure out how to pilot these things, you notice an amphipod in the corner struggling with his computer. He's trying to make more contiguous free space by compacting all of the files, but his program isn't working. You offer to help. He shows you the disk map, your puzzle input. He's already generated, for example. Okay. The disk map uses a dense format to represent the layout of files and free space on the disk. The digits alternate between indicating the length of a file and the length of free space. So disk map like 1, 2, 3, 4, 5 would represent 1 block file, 2 blocks of free space, a 3 block file, 4 blocks of free space, and then 5 block file. A disk map like 90909 would represent 3 9 block files in a row with no free space between them. Yes. Each file on the disk also has an ID number based on the order of the files as they appear before they are rearranged. Starting with ID 0, so the disk map 1, 2, 3, 4, 5 has 3 files, 1 block file with ID 0, a 3 block file with ID 1, and the 5 block file with ID 2. Using one character of each block, where digits are the file ID and dot is free space, the disk map 1, 2, 3, 4, 5 represents these individual blocks. Yes. The first example above represents the individual blocks. Okay, so there is the first file sec 3 spaces, then 3 file, then 3 spaces, then 1 file, then 3 space, then 3 file. Yes, okay, makes sense. The amphipod would like to move file blocks one at a time from the end of the disk to the leftmost free space block until there is no gaps remaining between file blocks. For the disk map 1, 2, 3, 4, 5, the process looks like this. So this is the starting position. Then we move the last two to here or switch the last two with the free space, then the second last two with the free space, and then the third last two we move here. Okay, this makes sense. The first example requires a few more steps, so this is representing this one. Okay. And the final step of this file compacting process is to update the file system checksum. To calculate the checksum and add up the results of multiplying each of these blocks positions or blocks position with the file ID number it contains, the leftmost block is in position 0. If a block contains free space, skip it instead. Yes, so basically all of the space in the end we will skip. Yes. Continuing the first example, the first few blocks position multiplied by its file ID number are 0 times 0 is 0. Yes, and then that is the first one, yeah, and then the 1 times 0 is 0, correct. 2 times 9, yes. 3 times 9, yes. And 4 times 8, yes. Okay, that makes sense. And the checksum is the sum of these, so we need to sum them up. Okay, let's get our puzzle input. And this is the disk map. We could even name it. It would be like that. And yeah, we need to connect first. To wait a bit, and then can we run this? And if we check the disk map, does it look correct? Yes. That's good. And so we know that there is files and free spaces. So the first number is file. So we know that every odd number is free space, and then every even number is file. So if we first would convert this disk map to look something like this, and then we could continue to do the kind of next step, which would be the file compacting process. So let's start by first converting this disk map to be the file blocks. So if we have file blocks, I'm not thinking that should this be list. Maybe it's easier to handle. And then for item in disk map, we will, so every item is then the number. So basically we want to actually enumerate this so that we can get the indexes as well. I think it should be looking like this. Yes, correct. And then if index is 0 or index modulo 2 is 0, so it's even. We know that it's a file. And then else we know that it's space. And for files we want to add the amount of okay, we need also file index to keep up with the file IDs. So what we want to do is that we loop through the item, or not loop through the item, but we need to insert the amount of the number that is set in the item. We need to input that number of items in the file index with the file index, or sorry, to the file blocks with the file index that we have currently. So how that would look like is for I in range of int item plus 1. So here we want to add file blocks.append. We want to add the file index, and then after all of this, we want to increase the file index with 1. And in case of space, we want to do this exact same thing. But instead of adding the file index in, we can add just the dot. And then in the end, we should have file blocks looking something like this. We can quickly check the starting that does it look good or sensible. So we should have 7 zeros. 1, 2, 3, 4, 5, 6, 7. Actually, we want too much or one too many. Oh, yes, actually, we can remove that +1 since actually we start from 0, so we have that kind of covered in already. So let's do that again. Important catch. So now we have this. So 7 zeros. Yes, and then we should have 4 dots, but we have the same issue here as well. So we now run it again. So 7 zeros, then 4 dots. Correct. Then we should have 8 ones. Do we have 8? 1, 2, 3, 4, 5, 6, 7, 8. Yes, we do. And then we should have 7 dots. 1, 2, 3, 4, 5, 6, 7. Yeah, it looks good. So we can say that this should be correct. And then let's clear that so it won't take that much space. Now, since we have the file blocks, we want to start compacting. And how to do that? So basically, we want to start moving stuff from the first or from the last position to the first space, and then update the position. So we should have the copy of file blocks, I would say. From copy import copy. Yes. So we want to have the file blocks copy of file blocks. My idea is that we could achieve this. Maybe the simplest way is that we would have just 2 iterators, one going beginning to the end, and then one from end to the beginning, and then the first one is taking the free spaces, the last one is taking just the numbers or the file items, and then they itself won't modify anything, but we will update the copied file block with the IDs or indexes, and then when we basically reach to the point where there is no or basically when we reach the point that the iterators are past themselves or past each other, then we can know that there is no more spaces before the upcoming numbers, and we can end it there. I think that is good idea to at least start with. So what we can do is that first we will do for index value in enumerate file blocks, and if value, we can check that if value is dot or is not a dot, we can actually is this now? Yeah, I think we can do it like this. So if it's not a dot, we can just continue, and then otherwise we just have a for loop. Similarly, we can actually just call it value1, or this should be space index, then for file index, then file in enumerate reversed file blocks. We then should check if file, or maybe we don't want to use actually this. Let's use just f, just in case, because file is a reserved variable. If this is basically space, then we want to continue. If space index is more than wait a moment, actually this is now wrong. We need to do this is returning enumerate, it is iterable. Can iterable be reversed? Let's double check that one. Enumerate 1, 2, 3. Okay, it's not reversible. So we should then okay, we can still handle this. We just need to take account that this file index is not actually the index, but we need to this is more like offset, so we need to calculate the actual file index. File index is basically length of file blocks minus 1. So we can kind of have the indexes. And then we want to subtract the file index offset. Yes. What it will mean basically is that if we have a base 1, 2, 3, 4, 5, and then we calculate this let's call that as S, and then offset would be, so if we are on here, it would be 1. So we should get the A from S. We should get 4. Yes, correct. So it should work. So now we have the file index. So if the space index is above file index, we can just break or mark the because we will break only this for loop, so we need to kind of break also. Should break should break is false, and then when this breaks, we can just set this true, and then after this we check if should break, we break here. Yes, so now we should have both space index and file index, and what we want to do is that, so we want to modify the file blocks. So we want to replace the item in position, in specific position, and then set the another to be space. So let's first start with the space position, space index, and then we want to set the file to be there, and then we can do the same for the file index, and then set the space there. And now if we run this, we should have quite nice file blocks, and then the original file blocks should be looking as it was. So if we now check the file blocks, how does it look? We can see that there is a lot of space. It seems that this is not actually working as it should. Let's see here, what is the file? So that is looking good. Okay. And how are these indexes evolving? So if we set indexes, and then we can check the space index and the file index. So if we start from the beginning, it has forgotten. What if we use this smaller example? And then we just use the example here. Oh, now it should be. Yes, and it looks good. Then if we run this, okay, it's not looking good. And indexes, okay, this is always on 2. Oh, okay, so after this, it should break. Okay, so we should break it anyways, but if we break because of the index, then we should mark it. Okay, so now if we check, it's looking way closer what it should be, but clearly it's not removing the files from the end. So we can see that it compacts it very well, but this is not correct. So what is the file index? It's always 41. Actually for this we need to use the copy. Yes, I think. There's this lonely 6 for some reason. It kinda maybe that needs, if file index is smaller than, I'm wondering why it's kind of skipping the last. Actually, we might not need this. Let's see how does it work if we remove that. It's looking otherwise good, but the last one is still. Last one is still there. I'm wondering why, because there is only 3 6s. Sorry, 4. And the first one is as it should. Second one is as it should. The third one is as it should, but the last one is in the original spot. So do we need to anyways, or here as well, use, I think we actually need, so do we need to do some kind of while true function here, which then would break and then, or maybe while true is not the best, we could just do in range of length while blocks. Maybe that could be the best or easiest. And then if we check, Okay, now we got it to the last one. Okay, we need to break this, I think, as well. And then we should have it. Yes. Okay, so now if we try it with the big or original disk map, we can see that can be compacted as wanted. That looks good. Then I would guess this step will take a bit longer. Maybe the prints are not. Let's actually pause it and remove the prints. Then add just iteration. Let's print the underscore. It should be a bit faster. And meanwhile, we could actually check what is the length of file blocks. What should we kind of expect it to be? Okay, it won't run it. So it's one cell at a time. So let's actually pause this, check what is the length. So 95. Okay. So now, since we know that, let's do so that I'll start running it and then speed it up for you, so you don't need to wait for the quite while. Okay, now we have the calculations done, and we can check the value of file blocks. That does it look good? It looks something what I would expect it to look like. Yes, truncated. Good. So now we have the files compacted. So we need to then continue to the next step. So we need to calculate or update the file system checksum. And how we do that is with this calculus. So basically what we need to do is that we can then once we know that it's just sum of these. So if we have checksum of 0, or we define 0, and then yeah, index and file ID in enumerate of file blocks. Yes. And then we do checksum plus equals, and then we want to so actually we need to check the file ID. If file ID is dot, so it's space, then we can continue. Otherwise we will multiply the file ID with the position. Index times file ID, and this needs to be integer, since it's string. and then this index, yeah. And then we can just run this. And then we can check the checksum. Now I'm a bit suspicious because it warned that be careful copy pasting the input for this puzzle since it's very long line. This is not very long line. So I'm now wondering that we have some error in our implementation, but let's see. Your answer is too high. Okay. So it should be actually smaller than this. Interesting. So let's check what kind of like the print index and the part ID. What we will get? Okay. And so 0 and 0, yes. 1 and 0, yeah, 0. Then 2 and 9. Can we then do if we would like to do this example, let's copy. I don't want to override anything, so let's just copy the stuff here, and then example, and then then yes. So if we call that one, we have the example value. Okay, good. Then if we copy this as well, clear code paste, then we want to have example blocks. And then let's do that. Yes, this should be relatively quick. Yes, we can clear it out. Then we can just check what is in example blocks. Does it look as it should? Yes. Yes, it does. Just to make sure. 6446 333 777 288 83189. Yes, looks good. Then if we actually delete this one and then calculate the checksum for this, we can actually leave it on, and then we can check the checksum. It says 1928. So it should be good. And why it's not working with this then? And it is the correct one as which I typed in or copy paste in. final step of this file compacting process is to update the file system checksum. To calculate the checksum, add up the results of multiplying each of these blocks position with the file ID number it contains. The leftmost block is position 0. If the block contains free space, keep it instead. So then we shouldn't actually... I see. So we need to actually change this a bit. So the problem is if there is spaces between, then we will increase the index, which we shouldn't do. And we can do that by just separating the index out of the loop, and then we can just increase the index by 1. So we should still get this. Okay, good. Then if we use the file blocks, do the same thing. I see. So previously we added this one, but now we got, which was too high. So this is a bit lower. Okay, so let's try this one. Okay, yes, good. So there was some space that needed to be taken in account. So that was kind of nice twist there. So we managed to get the part 1 solved for this day 9. I think it's good to end the video here so that it won't get too long. Thank you for watching. I hope you enjoyed the video. If you did, please subscribe the channel and like the video, and see you guys in the next video. See ya.